In this video, we're going to be talking about graphing sine and cosine as a function. And so to kind of start us up, I want us to look at this equation where I've set y equal to sine of x. And you guys are used to seeing equations like y equals 3x plus 1, a linear equation, or y equals x squared, something like this, a quadratic equation, and maybe something even like more complicated, like an absolute value function that's shaped like a V. And we've seen all different types of equation, but we can also write an equation using trigonometry, or more specifically, those trig functions that we've been learning about. So let's take a closer look at this equation here. Whenever we're talking about, a function, there is an input where we recognize as the x and the output as y. Now, I've chosen some inputs for us to plug in, and we're going to just try to find out what's the y value. And what might really help us here is using the unit circle. Let me get rid of this. This equation has sine, and we're plugging in 0 in for x. So this is going to look like sine of 0 radians. Well, if I want to know what sine is at 0, I have to look at the y coordinate at 0 radians. So if I look at my unit circle here at 0 radians, the y value is going to be 0. So I'm just going to highlight that portion. So I just care about the y values because my function has sine. And for sine, we've learned before, it's related to the y value on a unit circle. So when sine is 0, the y value here is also 0 on the unit circle. When sine is pi over 6, so now I'm going to plug in pi over 6 into my x. So if I go to my unit circle at pi over 6, the sine value, or the y value here, is 1/2. And then for pi over 4, if I were to plug that in, it just goes to the next y value on the coordinate system. So at pi over 4, right here, it's root 2 over 2. And then I can go to the next one, sine of pi over 3, which is going to be here, pi over 3 is root 3 over 2 for the y value. And for pi over 2, this is going to be right here, and the y value is 1. Now, you're probably thinking, okay, I'm making a table, I've been given some x values to plug in, and I'm finding the y values. Why am I doing this again? Well, it's because today we're talking about graphing. And when it comes to the foundational part of knowing how a graph of a function looks like, or the shape of it, what it looks like on a graph, you must build a table so you have an x and y values that will be coordinate points. And when you plot coordinate points, you can connect the dots to see what the shape of the graph is going to look like. Okay, so let's get ready to draw a graph here. So I'm going to do my best to scale this, but we're going to need a coordinate system. So let's draw a coordinate system. There we go. And we'll plot this point here is going to be x equals 0. And we have some x values, so I'm just going to plot them all. So we have pi over 6. We have pi over 4. So I can scale the x values and y values however I want. So I'll just scale it like this for now, just to kind of see what is sine curves going to look like. So to scale our y-axis here, I want us to take a look at these y values that we've collected. And I notice that I have a lot of fractions and radicals here, or roots. So I'm going to change them to decimals to make it a little bit easier to see what are my numbers. Like 1/2 is equivalent to 0.5 as a decimal. Square root of 2 over 2, if you put that in a calculator, it's about 0.71. And square root of 3 over 2 is almost 0.87 if I round to the second decimal place. So having it as a decimal when graphing is much easier to plot. So I can see like my lowest y value is at 0, my highest y value is at 1. So looks like I only need to plot this to 1. So here's my coordinate point. Starting at 0, this is a coordinate 0, 0, so I have a dot right here. So remember, these are like coordinates where you're taking the x value, 0, and the y value, which is also 0. At pi over 6, this is at about a half, so about a halfway point. So I'm going to plot right there. And at pi over 4, we have about 0.71, so a little bit higher. And then pi over 3 is just a little bit higher at 0.87. And then at pi over 2, it should be hitting 1. So if I were to like make a little dash line to show this, at pi over 2, it should hit about 1. And so if I connect the dots here, I can start to notice that a sine graph, or y equals x, y equals sine x, kind of has like a curve shape. And so that's what I want us to notice. But let me just say that this piece right here, this graph, is just a small piece of the sine curve. And here in a moment, we're going to expose what it looks like from negative 2 pi to 2 pi. So that way we can really see the shape of the entire sine curve. All right, so let's start with going back to making a table here, but I want to try some other x values that go all around the unit circle, like I have 0, pi over 2, pi, 3 pi over 2, and 2 pi. So you might notice that these values show all the axes of a unit circle, and so I want to go from 0 to 2 pi so we can see all the values from a whole unit circle. So again, I'm going to plug in these numbers into my function because I want to graph sine of x on a coordinate system. So again, I'll plug in sine of 0, and this was 0. Remember, sine is the y values on the unit circle. When sine is pi over 2, that's when sine is 1. When sine is pi, let's take a look at our unit circle and see what that gives us. So if we go back to our unit circle, sine of pi is right here. Notice that the y value here is 0. And then we're about to find 3 pi over 2, and the sine value there is, or the y value is negative 1. And then we're back to 0. So I'm going to grab those values and put them here. So at sine of pi, we had 0. At sine of 3 pi over 2, we have negative 1. And when sine is 2 pi, that is 0 for y. And so again, these are coordinate points that we need to find. And so once we're able to draw the graph in its form here, we're able to state the domain and range and something called an amplitude, period, and midline. But we'll explain what these terminology means here in a moment. So let's just draw our picture for now. So for our graph here, we have to draw a coordinate. So I'm going to do my best to draw a coordinate system. And let me zoom that in a little bit bigger. There we go. So we have from 0 to 2 pi. And so I like to draw from 0 to 2 pi first, and then I'll half it so I can show pi. Just makes it a little bit easier to scale. And then I'll half this, so I would have pi over 2. And then this part right here would have to be 3 pi over 2. And so this shows it from 0 to 2 pi. And I'm also going to do the negative side, even though we didn't plot it, but I'll show you how to get the negative here in a moment. So we have negative 2 pi, then half of that would be negative pi, half of that would be negative pi over 2, and then negative 3 pi over 2. So what I want us to notice is, what is the lowest y value here? Well, it's negative 1. So that means the furthest I'll go down is negative 1. The highest y value here is positive 1. And so I'm going to place a positive 1 up here so I can reach that far. All right, from here, I need to plot my points. So my coordinate points, I have 0, 0 for the first point. That is the origin. So I'm going to go down here to the center to plot that point. At pi over 2, I have 1. So from pi over 2, I have to go up 1 unit. And then at pi, I'm back down to 0. And then it goes further down to negative 1 at 3 pi over 2, we can see it's a negative 1. And then at 2 pi, it's back to 0. So that's back to the x-axis. So when I draw this picture here, I know that I'm supposed to curve when I connect the dots. The reason why I know that is when I was drawing a short sample of it, I noticed this curving when I were plotting the points, and these were smaller x values that I was working with. Notice that this one goes from 0 to pi over 2. Well, that's this piece right here that I've just connected the dots to, but now I'm drawing out more points. So I need a curve when I connect the dots. All right, so from here I have my points plotted, and now I'm going to try to graph my other part on the negative side. So one of the cool things about a sine graph is that it oscillates. And what that means is that you see this wave here, it just keeps doing this wave shape as it further extends onto positive infinity for the x direction, but also for the negative x direction. So if it were to keep going, it just goes like a wave, up and down and up and down. So if I were to follow this wave, this would kind of go down and back up and down. So if I follow that pattern at negative pi over 2, it would go back down. And then at negative pi, go back up. Kind of like this part right here from pi to 2 pi over 2 kind of went down. Well, this goes down. So you can kind of predict that this piece would go back up and probably back up to the highest point here, which is positive 1. So that's one of the cool things about trig functions is that they do this repetitive pattern. Let me see if I can curve that. And notice that when I'm connecting the dots, I'm really curving that graph because sine graphs, and later on you'll find out cosine graphs has this curve characteristic. So let's check out the domain. A moment ago, I mentioned that for the x values here, as this were to extend on to negative infinity and to positive infinity, this sine graph just oscillates. So that means it keeps going on and on forever in that continual shape. So really, I have like arrows kind of showing that the sine graph will keep going on forever. So the domain is always going to be going from negative infinity to positive infinity on the x-axis. So the domain here you can say is negative infinity to positive infinity. Or some people like to use this notation, all real numbers. This is usually more my preferred method, but some people need to see the infinities to understand what it means. As for the range, there's a little bit of restriction. I want you to notice that the lowest points that a sine graph can go is negative 1. That's very typical. So for a original sine graph here, or what we call the parent function, which is the original function that hasn't been shifted, this here, the range lowest point is negative 1. The highest point is positive 1. And so I'm going to use brackets to show that it goes between those numbers because it actually touches at negative 1, it actually touches at positive 1. So I want to use brackets. As for amplitude, amplitude means that from the what we refer to as midline. Midline is the middle part of the graph. I want you to notice that the middle part of this graph would be the x-axis. And we use the y values to refer to that. So on the x-axis, the y value is, let me grab a pen here. So when you're sitting on the x-axis, the y value here is always y equals 0. So the midline here is y equals 0. As for the amplitude, that tells you how far up or how far away are you from the midline to the highest point, top and bottom. And they should be the same length if you're talking about a sine curve. So I want you to notice if you were to look at the length of the amplitude from the highest point, which is in this case, this peak right here, to the midline, that is about 1 unit. So the amplitude here, let me use a darker pen, the amplitude is equal to 1. And also if I were to kind of measure it from this side here, from the midline to the furthest part down, it's also 1 unit. Even though it's in the negative direction, this is 1 unit away from the midline. So amplitude is always a positive number. It just shows you the distance away from the midline. So in this case, this is 1 unit. The period, we'll talk about period later, but for now, period just means how far or is one cycle. So, or the length of a cycle. So notice how this sine starts down here at 0, goes back up, comes down, and then comes back up to 0 again. So this is one revolution. So one revolution goes from 0 to 2 pi. So the length here is 2 pi for one revolution. And later on, we'll talk about when the period gets shifted or changed around instead of being 2 pi. But for now, the length of a period is always 2 pi. All right, let's talk about cosine. So we're going to do the same method here for cosine. We need to graph the points by plugging in some x values that I've strategically chosen. So I'm doing x values from 0 to 2 pi. And because now we're dealing with cosine, if I plug in 0 for the x here, I have to look at cosine. So on the unit circle, I'm looking at the x values this time on the coordinate system. So if I go to 0, this is my radians angle on the unit circle here. At 0, I can see that my x value is 1. So cosine of 0 is 1. Cosine of pi over 6 is root 3 over 2. Cosine pi over 4 is root 2 over 2. And then if I were to go to cosine of pi over 2, well, the x value here is 0. So what I'm going to do is grab the x values off of the unit circle. So feel free to use your unit circle so you can kind of see what values I'm pulling off and make relationships. So cosine of pi over 2 on the unit circle is the x value, which is 0. Oh, I forgot to put a 1 here. And then cosine of pi, well, that is going to end up being -1. The x value there is a -1 at pi. Cosine of 3 pi over 2 is 0 for the x value, and cosine of 2 pi is back to 1. Notice how where I start and where I end up being the same places. Okay, so from here, we're going to make our graph and then figure out domain and range and all that other stuff. So drawing a coordinate system down below. Actually, let me extend that so I can make room for the negatives. So for cosine here, I need to make my 0 to 2 pi. So again, I go all the way out to 2 pi, and then I half it, so I know that that's pi. And then I half that, so that's going to be pi over 2, 3 pi over 2. I'll go out to here to -2 pi and do the same thing in the negative direction. Okay, so from now on, I need to graph the y values, and the lowest y value here is -1, so kind of like the same as before. And my highest y value here is also +1. So if I were to graph my points, I have the first coordinate at 0, 1. So instead of starting at the origin, I actually start up here at y equals 1. And then it goes down from there. So pi over 2 is 0. So I'm on the x-axis now. And then at pi, it's at -1. And then 3 pi over 2, it's at 0. And then 2 pi, it's back to 1. So this shape's a little bit different. But for cosine, it's also in a curved shape. So it curves down, curves towards the bottom, curves back up. So cosine is iconically known to look kind of like a U shape, at least when you're looking at the parent function. It kind of looks like a U or dip. And then it also osculates, so this can go on forever and ever on the positive direction. And it's same thing, it goes on and oscillates to the negative side as well. So if I were to show the negative, then we can kind of see like this is going to be a reflection. So if this went down, this negative 2 pi over 2 is also going to go down. And then it's going to go further down to negative 1 when we get to negative pi, and then back on up. And then when we get to 2 pi, it goes back up to positive 1 again. And so creating that same U effect. And notice that it oscillates. It looks like the same repeat on this curve here. So this part's going to negative infinity. So my domain is also going to be all real numbers because this goes from negative infinity to positive infinity because the cosine graph also oscillates. Oops, let me grab my other pen. So that's going to be negative infinity to positive infinity or all real numbers. As for the range, it's also from negative 1 to positive 1 because you can see on the graph here, the lowest point is at negative 1 and the highest point for the y values is positive 1. So it doesn't get any lower than negative 1 and positive 1 for the parent function or the original function for cosine. So this one has not been shifted yet. As far as amplitude, so for this graph here, I do want to mention the midline for cosine graph is also on the x-axis. So right here, notice that this would be considered the middle part because you can kind of see like the amplitude should be an even number going, or the same number going up and the same number or length going up and the same length going down. So if we choose this as our middle ground, you can see that the length going from 0 to 1 is about 1 unit, and then from the midline down would also be 1 unit. So this piece right here is our amplitude. And it is about 1 unit. And same thing down here, it's about 1 unit from 0 to 1. So our amplitude is 1. I think I forgot to make a line here, my bad. The midline here is at y equals 0. The period, if you look at the shape here, it starts from 1, y equals 1, goes down and back up, and then just repeats. So it looks like the length or the x value starts at 0 and then goes to 2 pi. So the length here is also 2 pi for the period. So period, again, tells you the length or the x value length of the revolution. So one revolution here is this U shape, and we can see that this U shape starts up, comes back down, goes back up. So this characteristic is extended from 0 to 2 pi, so I know that that's about, that length is 2 pi. And so that's going to be referred to as our period. All right, so I'm going to end the video here. In the next video, I'll continue practicing problems looking at cosine and sine graphs.